Let's discuss about the next one, alert codes. A TLS supports all of the alert codes defined in SSL version 3 with the exception of no certificate. A number of additional codes are also defined in TLS. Let's see about the additional codes defined in TLS. The first one, record overflow. A TLS record was received with a payload ciphertext whose length exceeds 2 to the power of 14 plus 2048 bytes, or the ciphertext decrypted to a length of greater than 2 to the power of 14 plus 1024 bytes. Unknown certificate authentication. A valid certificate chain or partial chain was received, but the certificate was not accepted because the certificate authentication or CS certificate could not be located or could not be matched with a known trusted CA. Access denied. A valid certificate was received, but when access control was applied, the sender detected or decided not to process with the negotiation. So hence, this is going to be coming under an access denied. A decode error. A message would not be decoded because either of field was out of its specified range or the length of the message was incorrect. Protocol version. The protocol version the client attempts to negotiate is recognized but not supported. Insufficient security. Returned instead of handshake failure when a negotiation has failed specifically because the server requires cipher more secure than those supported by the client. Unsupported extension sent by clients that receive an extended server hello containing an extension and not in the corresponding client hello. Internal error. An internal error unrelated to the peer or the correctness of the protocol makes it impossible to continue. Next one, decrypt error. An handshake cryptographic operation failed, including being unable to verify a signature, decrypt a key exchange, or validate a finished messages. Some of the remaining alerts also there in that is user cancelled. This handshake is being cancelled for some reason unrelated to a protocol failure, and no no renegotiation sent by the client in response to a hello request or by the server in response to a client hello. After initial handshaking, either of this message could normally result in renegotiation, but this alert indicates that the sender is not able to renegotiate. This message is always a warning. Let's continue the next one as cipher suit. There are several small differences between the cipher suits available under SSL version 3 and under TLS. Here actually the symmetric key encryption algorithms are going to be get used over there. Here we can say that the key exchange and symmetric encryption algorithm are the two. What key exchange? TLS supports all of the key exchange techniques of SSL version 3 with the expression of force. And symmetric encryption algorithm TLS includes all of the symmetric encryption algorithm found in SSL 3. Next one, a client certificate types. What actually the client certificate type? TLS defines the following certificate types to be requested in a certificate request message. Actually, we are going to have a certificate verify message and certificate finish message. In generally, the message may be an RSA sign or DSS sign or RSA fixed or DH and DSS fixed DH. These are all defined in SSL version 3. In addition, SSL version 3 includes RSA imperial DH, DSS imperial DH, and FORTISA KEA. Imperial Diffie-Hellman involves signature the Diffie-Hellman parameter with either RSA or TSS. For TLS, the RSS sign and DSS sign types are used for the function. A separate sign type is not needed to sign Diffie-Hellman parameters. TLS does not include the Fortizza schema. Hence, we are going to see about the certificate verify message and the certificate finish message. In this TLS certificate verify message, the MD5 and SHA1 hashes are calculated only over handshake messages. Just we can recall from the SSL version 3 what we have come across over there. The hash calculation also included the master secret and pads. These extra fields were filled to add no additional security. As with the finished message in SSL version 3, the finished message in TLS is a hash based on the shared master secret. The previous handshake message and a label that identifies client or server. The calculations somewhat differ. For TLS, what we have, PRF master secret finished label, MD5 handshake message concatenated with the SHA1 handshake messages. Where finished label is the string client finished for the client and server finished for the server. Cryptographic computation. The pre-master secret for TLS is calculated in the same way as like in SSL version 3. As in SSL version 3, the master secret is created. In TLS is also calculated as a hash function of the pre-master secret and the two hello random numbers, client hello random and server hello random. The form of the TLS calculation is somewhat different from the SSL version 3. Actually, the master secret has been created and the algorithm is performed until 48 bytes of pseudo random outputs are produced and generated using a secure key exchange of RSA or Diffie-Hellman and then hashing information. Hence, the form of the TLS is master secret is equal to P or F of pre-master secret, master secret, client hello dot random is concatenated with the server hello dot random. This calculation of this key block material, which consisting of an max secret key, session encryption key and IVs, which generates cryptographic parameters like client write max secret, server write max secret, client write key, a server write key, a client write IV and a server write IV. Hence, which generates the hashing master secret. Hence, the calculation of the key block material is defined as key block is equal to PRF of master secret, key expansion, security parameters dot server random concatenated with security parameters dot client random until enough output has been generated. As with SSL version 3, the key block is a function of the master secret and the client and server random numbers, but for TLS, the actual algorithm is different. Let's see about the next topic, padding. In SSL, the padding adds prior to encryption of user data in the minimum amount required so that the total size of the data to be encrypted is a multiple of the cipher's block length. In TLS, the padding can be any amount that results in a total that is a multiple of cipher block length up to a maximum of 255 bytes. For example, if the plain text plus MAC plus padding length byte is 79 bytes long, then the padding length can be 1917 and so on up to 249. A variable padding length may be used to frustrate attacks based on an analysis of the lengths of exchanged messages. Hope that we have come across with the particular version number of TLS message authentication code functions, the function of pseudo random function and its description, how the HMAC has been created, the length for HMAC, and alert codes, certificate verify and finish messages, and cryptographic computations. Finally, we have been ended with the padding. Hope that this video may be helpful to understand about the transport layer security for you guys. If you have any doubts, kindly you can post your queries to me. Thank you for watching this video. Thank you.